So finally we get to our assignment and start looking at the actual the idea of high-speed multiplication of a 32-bit integer by powers of 2. Every CPU instruction in our program must be accompanied by a brief comment, so you can re-examine the code that I write. So I do my best while thinking about the presentation and typing some of this code, but you can always improve what I do. So this is the focus of our attention. Consider arithmetic multiplication. So the product is the result of the multiplier multiplied by multiplicand. So with this in mind, we're going to write a program which we'll just use in our main procedure. We'll have an endless loop, and we're going to do the following steps. We're going to ask the user to enter unsigned integer multiplier. Okay, so the multiplier is going to be an unsigned number. Store it as a double word value in memory. Okay, so we can start by doing this. Let's replace this double word right here by something that we can call a multiplier. Right, so we're just going to do the first multiplier, and this multiplier we can initialize to 0. Okay, so we have multiplier is an integer. So we're going to ask the user to enter this multiplier and store it as a double word value in memory. Okay, so what we can do next is just move the stack to the top to keep constant data segment next to the data segment right here. And I'm thinking that we are going to need a couple of buffers to be able to do the conversions and accept user input. So I'm going to add these two at the top. Okay, so there is memory to get user input, and there is memory to convert integers to text. So these are, if you recall, we've used these buffers in the past in laboratory 8. So let's work on the part that we can ask the user to enter this multiplier, of course using our input-output macros. So I'm thinking that we may need to communicate with the user, and essentially we need to say something like we can prompt for the multiplier, and that might look like this, right? So input multiplier, and this is just a string that we're going to display. We also have end of line if we need to print that. I am expecting that there is a possibility that they will enter bad input for an integer, so let's also have something that says bad format, please retry, so we can let the user to retry this input right away. All right, so let's get started, and I'm thinking that because they may need to be able to retry, so of course I'm not going to use any of this anymore. In fact, I'm just, for now, I am going to just get rid of this portion of the program and do just like, highlight the label right here. So this is our multiplier input. And because we may need to be able to repeat this, this is just a label, right? And these are just comments. So first of all, we're going to do the prompt, ask for input, then we're going to do the input. I think this may look like this. So we're going to print enter multiplier. Then we're going to get input into the buffer. We have a buffer of 12 bytes reserved plus 0 terminated character at the end. And we're going to convert this buffer into register EAX. So if you recall, the A to D ASCII string to double word, that's the name of this macro, may fail, and it will set an overflow flag if it fails. So we can handle this, I think, next portion as this. So I'm just going to add this portion right here. This is the new portion of the code. So we say if no error, just jump forward, and I immediately store EAX as our new multiplier. If we have some sort of bad format, we print error message, print end line, and we jump right back to the multiplier input. So this could be a loop as long as user enters incorrect values here, the loop will continue. So I think we're done with the multiplier input, and should be able to accept this input. And in fact, let's take our multiplier, and in fact it's already loaded in EAX. So if we run this program, we should be able to display the multiplier input as a binary digit at the end of our output. So let's build this and run it. Control F5. So input multiplier. How about we enter 1? Okay, so that's not too bad at all, right? So we have basically 1, 2, 4, and 5 bytes in memory filled with these bits, and of course this corresponds to 1. Okay, so this looks pretty good. So that's a good start. So we have made progress through first portion of this assignment, and in fact we already need to display, so we already passed the second part in this to-do list.